Let's take a look at addition in unit form. This is going to lay a good foundation for when we start doing addition in the regular form or the standard algorithm. If we look at this four-digit addition problem, 3,134 plus 2,493. What we really do in addition is we consider our place values and we add each place value. So let's use a place value chart to help us really figure out what these numbers are. I used blue dots here to represent how much I have in each value or how much I have in each place value. I have 3,000s, 100s, 3 10s, and 4 1s, representing the number 3,134. I'll use red dots here just for the purpose so you can keep them separate. The red dots represent my below number, 2,493. 2 in the thousands, 4 in the hundreds, 9 in the tens, and 3 in the ones. So when I add using my place value chart, what I'm doing is I'm adding all of my ones together first. I have 7 ones. Then I move to the next place value, the tens. When I count all of my tens up, I find that I have 12 tens. Now the students know that this is a problem because we can't have a two-digit number in a place value. So we're going to have to bundle or regroup. I look for 10 to send over to the next higher place value. So I had my 9 reds and I took 1 blue, put them together, and I'm bundling and sending over one set of 10. I'm representing here with a little X. I'm covering up my 10 because it's being sent over to the next place value. The remaining units in the tens place value that were not bundled are 2. So that's what I have left. And then I'm going to count the remaining place values. I have 6 in the hundreds, the 1 blue, the 4 reds, and then 1 additional green, that green that I bundled over, and 5 in the thousands. So now I have a total, after counting all of my units, 5,627. You can see where I place this in my original math problem up here, 5,627. When we take a look at this problem and start to use the standard algorithm, algorithm being a fancy math word for the way you do stuff, we'll add up our columns, our place values the same way. 4 plus 3 equals 7. 3 plus 9 equals 12. Now notice a different way that I'm referencing the regrouping or the bundling here. I know back when I was younger, and maybe the traditional way that other people learn this, we put our 1 on the top. I suggest that we put the 1 down here. It still looks like the number 12, the 9 plus 3, still looks like the number 12, but I'm regrouping that 10, bundling it, and sending it over to the next place value. It's just a different way to look at it so that you know that you did originally come up with 12. And this 1 that you sent over was 10. And then you add up the remaining, 5,627. Let's do this with some larger numbers. I've already placed my units on the place value chart, representing the 2 addends, or the 2 numbers that I'm adding together. Starting off, I count up all my ones and I get 5. I take a look at my tens and I realize, oh, I probably have more than 10 tens. So I'm going to bundle 10 of them together and send 1 over. And then I just complete the rest of the problem. 3 of my tens did not get bundled, so that's how many I have. In my hundreds, when I count all of them together, including the one that I had regrouped, I had more than 10 again. I group a set of 10, send it to the next place value. The 2 hundreds that did not get bundled are what I write. I now have 1 thousands and I have 7 10,000s. So when I look at my number, my answer is 71,235. Using the standard algorithm, we have 71,235. These little ones here represent the regrouping or bundling. So the 1 and the 3 diagonally show my 13 that I had in total in the tens. The 1 and the 2 show the 12 that I had total in my hundreds, but I'm putting them here, lining them up with the next place value so I know where to add them. And this is how Engage New York suggests that we represent addition.